You are watching tip 709, which is part 4 of my series on the South Bend grinding jig. And in this episode I will be demonstrating its actual use and will be grinding bits. In this video I will be grinding or sharpening a right-hand turning tool as shown here, and there are all the angles, and if time permits I will also grind a right-hand side tool, and actually we call that a facing tool, and there's examples of their use. This is the actual sheet that came with the South Bend block, and I have reprinted these instructions which I have just shown you, and here are some examples of how it is used, although I prefer to do my grinding on the periphery of the wheel rather than the side of the wheel. These are the instructions that originally came from South Bend in the box with the cutter bit grinding block. There will be a still picture of this at the end of this video. If possible, get yourself a copy of this book. Of course, it's from 1935, so you will not find it at Kmart. This wonderful picture is out of the South Bend How to Run a Lathe book. Hello once again, it's Mr. Pete, your YouTube shop teacher, and this is part 4 of my 4-part series, all about making and using the South Bend bit grinding block. So make sure you watch the first 3 parts. But if you're interested in how this is actually used, that's what we're going to do in this video. Now, I am not going to talk a whole lot about the angles and the geometry and all that good stuff. That will be in a follow-up video, along with talking about grind wheels and how to dress grind wheels and how even to make a dresser for your bench grinder. And I'll be using a lot of reference books, and I won't talk much about these now, but get yourself one or more of these books. There's the South Bend How to Run a Lathe. It's the Boxford book for you guys over there in Britain. There's the Atlas Craftsman book and the Sheldon book, and they all have excellent sections and instructions on grinding tool bits, all about the angles and things like that. Now, I do understand that 90% of you guys out there either do not have a machine at all, you're just watching this for the pure fun of it, or you are using carbide. And I'm not covering carbide at all. I do use carbide, but I also use high-speed steel quite a bit. I just find I get a better finish with high-speed steel, and I can grind the tool exactly like I want to. Now, you can grind these bits by hand much faster than with this little jig, but if you've never done it before, it'll really help you to understand the angles and get consistent angles, and you'll have success. It's very difficult to learn this just by yourself, and you'll have probably a lot of failures and discouragement. So this video might help you. Now, 10 years ago I made a video, and actually several of them concerning this, so there will be some repeat, or you can go back and watch that if you want. Alright, enough blabbering here. Let's get down to the business at hand. Let me talk real briefly here about high-speed steel, and I have a whole bunch of these blanks, and you can get them from any industrial supplier, but you know, they're getting expensive. They're $4 or $5 for just one of these. So I recommend practicing on just common cold rolled steel because it's cheaper, you will be able to grind faster, and when you fail, if you fail, just cut the end off and start over. You can't do that with high-speed steel because it's either too expensive or time consuming. But you can get at any box store, Precision brand, well, that's the brand, you can get key stock. So there's 5/16, quarter, just all the different sizes that you might need, and cut it off the length, and you can see that's what I've been doing here. Cut it real long, and you can practice on it, cut it off and do it over and over and grind both ends. There's just endless possibilities. So with the high-speed steel now, you're going to find some that is more black in color, and you're going to find the slightly more expensive ground stock. You may have trouble fitting some of the unground ones in the various sleeves here. So, and if you do, just put this on your belt sander and sand it just a little bit on each side, and then it will probably fit. So that is my suggestion. Just 2 weeks ago I went to an auction and I had to pay 20 bucks for this South Bend stainless steel grinding gauge for tool bits. I'll talk a lot more about this later. And I might make a video on how to make one of these. They do not need to be real accurate, but they're kind of handy and neat. I do like this because it has the South Bend logo on it. I do not think you can buy these anymore unless somebody is remaking them, but I thought that was pretty neat. Now in part 1 I told you that there are no blueprints or plans for making this little grinding block, but I now have actually 4 people that have participated and made drawings for me, and they are available on the website called My Heap. I've talked a lot about that before, so go to that website. You can download them and print them out. You can print them all out or just your favorite or whatever. And thank you to those guys that made those nice drawings for me, and I'm sure they will be useful to many of you, and I'll put a link in the description below. Welcome to my channel. If you are a student in a classroom, high school or college someplace, and thanks to your teacher if he's using my videos, and I hope this helps you a lot in your instruction, although I don't know if this is being taught anymore in schools because I think they're leaning toward carbide. But when I was teaching back in my prime, imagine standing in front of a class of 24 kids and trying to explain the angles on a small tool bit like this. So I developed these teaching aids over the years, small ones and large ones, to explain those angles, and particularly this one here. And this is the first one that we're going to grind today. It's a right-hand turning tool, probably the tool that you will use the most. Matter of fact, 90% of the time this is the tool that I use. Now there's a lot of variations in these, and you'll see that in those little booklets that I just showed you, but these are the South Bend shapes, and they are very useful, and I probably have become the standard of the industry, but they aren't the only ones. But you can see here that there's all kinds of different angles that we're grinding, and different number of degrees on that. I'm going to get a little bit more into that in a minute, but we also have here a facing tool and various other shapes that I'm not going to deal with at all, but these are pretty handy. So let me show you another one that I have. Okay, here's a block that I have prepared, and again, this will be a right-hand turning tool or a facing tool. It doesn't make too much difference. But the very first thing that we're going to do is to grind this. So I will remove that. I got a little bit of tar on there to hold that together. But that is the first angle that we're going to grind, and it's about 10 degrees. And the word relief is the same as using the word clearance, so I may use those interchangeably, but I grind that first using this, or you can do it freehand once you get pretty good, and then we'll proceed on the grinding wheel to grind this angle. And after doing that, you can see that we have our end relief. This is side relief, this is end relief, and then finally we grind the top, which is the rake angle. And there's a combination there of side rake, this is the side rake, and a little bit of back rake. That's when we tilt it up. So those are the 3 angles that we're grinding. And then on the turning tool, we'll make just a little bit of a radius on here, and that will give you a nice smooth cut rather than a real sharp cut. Now it's important to remember now that all of the cutting that you do on the lathe takes place right here near the end. All of the other angles and clearances and everything you see are just to produce that little area there, and that is the area also you will see will dull or chip if you're careless, or over time of course it's going to dull, as all tools do. So I hope this helped you. Remember, this is what we're going to grind first, if I can get it on there right. And that is the most material that we have to remove. Okay, this is the South Bend factory jig that I own. I got from Henry. I'm going to set that aside. I'm not going to use it. I want to use the one that I made in the first 3 parts, And I believe for the sake of clarity and making it a little bit larger, I'm going to use a 5/16. So I only made 2 sleeves, remember, 1/4 and 5/16. You only need to make sleeves that will be correspond to the size that you're going to use. So this is 5/16, and I'm going to again use cold rolled steel. This is actually key stock, as I said. So I'm going to cut that off, but that's what it's going to look like. Now you're going to get quite a nasty burr with soft steel as compared to using high-speed steel, and I won't even bother removing that. But I'll show you how to hone your high-speed steel on an oil stone. These are pictures out of the South Bend book, so again we're going to make a right-hand turning tool. That's how it's used, and I might do the right-hand facing tool, but you see I've already run out of 10 minutes of video, and I don't want to make it too long, but the angle on the end here is about 85 or 90 included on a turning tool, and it's less than 60, usually about 55. In other words, it's more of a point, 58 degrees, and the reason for that is that it allows you to face off your work when your work is held in a center without striking the center. The turning tool would not fit in there. Do you do this very often? Not really. So really this is the one we'll concentrate on, and you can see here that that's more of a radius, a larger radius than what I'm going to put on there, but there's 10 degrees rake angle, 10 degrees side relief or clearance, and then we got, we got between 20 and 30 degrees end clearance. That can vary a lot. Remember, there's a lot of wiggle room here, and it'll still cut and it'll still work. Now, if you are a beginner, it might help if you put layout die on the tool and actually scribe the shape that you're going to be grinding, because we're doing 2 things here. We're grinding it to shape, and we're trying to produce the clearance angles that I talked about. But using a scriber, come over about 2/3 of the way, that's right about here, and draw an angle down. I doubt that that's showing. I'm looking in the monitor. Yeah, it is showing. And then also over this way at about approximately 90 degrees or a little bit more. Or you can use a fine point marker like this, but your tool is going to get hot and probably and then you have to cool it in water, so you're probably going to lose these marks, but just trying to give you little helpful tips here. In part 3 I showed you how to make the graduations, and I've got the 0 witness mark there with a little bit of red on it and 0. I didn't stamp the other angles on there because I told you it's difficult to stamp on a round surface, but every 90 degrees I put a little center punch mark. Now we're not going to use those anyway. We're going to do everything on this side here near the 0. Remember that each graduation is 5 degrees. So we're only going to use, let's see if I can point it out here, 10 degrees on this side of 0 and 10 degrees on the other side of 0. So I'll go ahead and insert this in the block. You need to allow about 1 inch hanging out, or you might strike the block with your grinding wheel. Ask me how I know. Okay, I'm on 10 degrees, and I will tighten this like so, and we're ready to go over to the grinder. Finally. I shall be using this Craftsman 7-inch grinder. This is a medium wheel, this is a fine. I'm just going to use the medium. It would be nice to use a medium or a coarse and then finish up with a fine, but I really do not want to do that for photographic purposes here. Now, we were taught not to grind on the side of the wheel, now, because you really can't dress that. But that's what the instructions show. But I'm going to grind on the periphery. It's very important that you dress the wheel and I'm going to have a whole video on that and wheel dressers and all of that, so I'm not going to do that in this video. Also, this tool rest is way too small, as is probably yours, to fit on there. So what I did some years ago, I made a larger tool rest that was on this side, but even this wasn't quite big enough, so I took the time to make this. You know, it's about 6 inches by 6 inches, probably bigger than what I need, but that way the device will sit on there quite nicely. Now, one other thing, for photographic purposes, I'm going to move the guard out of the way. Do not do that. I'm only doing that so the camera can get in there. I will be wearing a shield. Actually, I suggest that you do too. And all of my life, I have done this safety item here. When I turn this on, I step off to the side and I turn my back to the grinder. Now, I've never had a wheel break or explode, but it could always happen, so I'm just saying, you can't be careful enough. The reason for dressing the wheel is you might have grooves in it, it might be glazed, it might be loaded, and more than likely it's out of round, that is, it lopes, and that'll be a problem for you, and dressing will eliminate that. And then every once in a while I take my diamond, I won't show that, and I run that across it real briefly, because you can see that it's glazed up a little bit, and the glazing, it's not really being loaded so much as I'm dulling the wheel with high-speed steel. This will not dull it quite as much. Okay, now I'm ready to start, and I'm going to grind, as I told you, this side first. And when I do that, I'm going to, again, this is at 10 degrees, I'm going to grind it on the flat like that. This is called the heel. So I'm not going to use the heel right away. I will use the heel when I do the other side. So this is what I'm going to do, and of course it's going to get hot, so I'll have to dip it in the water periodically. I do not care if it turns blue, because this is a practice piece, and even turning blue or brown on your high-speed steel will not actually hurt it, but it might annoy you some. Before I start, let me make a correction here. I'm going to loosen this up, and I need to turn this to 10 degrees on the other side of the zero, and then tighten it, or I would get a reverse angle. Okay, notice how nicely that side clearance is being produced. Also that I have one smooth facet on there, because every time you put this back on the wheel, it will be consistent. That is, you won't start another regrind like you would offhand. Did you also notice that the sparks were real orange? Later on, when I use high-speed steel, you'll see that the sparks are much whiter. Now, I'm not going to show everything here because it'll take too long. I will take it down to the final shape about 2/3 of the way across, and again about down to where that red mark is. Okay, I have finished grinding the side clearance. See the angle there of 10 degrees? And notice how it's all one smooth surface. That is, it is not faceted like your wife's diamond ring. And this is what you'll typically get if you're careless, and there might be 2 or more facets on there. Not desirable and does not look good. Now what I'm going to do is show you, well, let me show you this, that in review, this is what I have ground so far and produced the side clearance. Now I'm going to grind the end clearance, and in order to do that, here's what I need to do. First of all, I'm going to loosen the set screw and move this to 10 degrees on the other side of the 0. Need my glasses on. Tighten it down securely. And now I'm going to grind on the heel, or use the heel here, and I painted that blacks. In other words, before I was grinding on that surface, now I'm going to be up like that. And move again back and forth across the wheel so you do not groove the wheel. From this view, I think I also want to show you that be sure and make your little table or your tool rest low enough so that the tool is approximately on the center. This is the center of the wheel here. So I'm more or less on that. I am a little bit above, but it'll be all right. You don't want to be way up here. Also note that since we're grinding on the periphery, the grinding marks here are concave. They're not perfectly flat like they would be if you were on the side of the wheel, or if you were, ideally we'd like a dished wheel or a cupped wheel, and then we could work on the side and we could dress it properly, but this isn't really dressable. Now, in order to get an 85 or 90 degree angle here, if I take the surface that I have just ground and make it perpendicular to the axis of the grinder, that is like that, I will end up with the correct angle, and you can just eyeball that, or you can go ahead and mark it with a scriber or with a little red marker that I just showed you. Can you see the end clearance? Now we'll take a gander at it from a bird's eye view, and I'm going to grind the rake angle on, which is this angle right here. So I'm going to remove that much, and so I will do that by this method. I can leave the setting here the same at 10 degrees. That does not have to be changed, but I'm going to roll the block over on its side, and on the corner of the wheel here, I'm going to start grinding until the grind mark comes to the cutting edge right here. Furthermore, to get a little back rake, rather than have the tool bit parallel to the shaft of the motor, I'm going to move it a little bit like this. Can you see that I'm, I don't know what I am, 5 degrees or approximately. And now I'm going to turn the grinder on and push it in. I can't really move it back and forth too much this way. That's why it's nice to have a dressed wheel, and you can see how this is glazing up on me. You do not want a rounded corner on your wheel. You need a corner that is relatively sharp. All right, here we go, and then we're done already. And this represents, in real time, about 10 minutes of grinding, but you probably could do it faster with a coarse wheel. Very good. Very good. No, I have to take it off a little bit more. I can still see some unground surface there, so I'll do that off camera. Okay, I'm back at the grind wheel now, and I'm using the genuine South Bend with a 1/4 inch sleeve in there. This is a 1/4 inch bit, obviously. Notice that when I set this up, and it's at 10 degrees for the side clearance, two things. First of all, you'll see that the color of the spark is much different. And secondly, a lot of the bits that you buy have an angle on the end of them. So use that angle to your advantage, and you are already a bit of a head start with your end clearance. Otherwise you have to overcome that, and there's more grinding involved. I'm sure you do not understand what I just said, but I did have a point. So remember, now on this 1/4 inch bit I'm going to do a facing tool. So we'll start with the side clearance on this surface, not the heel. I'm not sure what we call this, but it's not the heel. Here we go. I do not like the color of that light, but it does take the shadow out. And when I'm speaking, you know, I'm talking through a shield, and my vision isn't that good, and I'm looking through prescription glasses and safety glasses and a dirty shield. So I'm under quite a bit of a handicap. Here we go, and I certainly am not going to show all of this because the video is already incredibly long. Okay, looks real good. Remember, this is a facing tool now. Don't worry about the blue, the overheating a little bit. It will not hurt a thing. So I want to include an angle here of about 55 degrees, so I will loosen this set screw and turn to 10 degrees on the other side of 0, and now I'm going to produce the end clearance, and I'll be working on the heel. This one isn't marked, but that's the 10-degree heel right here. Okay, that's looking good. You can see that I've got a lot of end clearance on there. I haven't measured it yet, but the included angle of the end using a fishtail is approximately 60 or just a little bit under. Now I'm going to put the rake angle on there, and that will be identical to the way I did it before, so I will not show that. So I'll meet you over at the bench in just a minute here. And what we'll do is examine both this 1/4 inch one, which is the facing tool, and the 5/16 square, which is the turning tool, and I still need to put a little bit of a radius on that turning tool. Back at the bench, 1/4 inch, 5/16, facing, turning. I'd like to put a little bit of a radius on this. Now, I could take this over to the grinder, but the grinder cuts so incredibly fast that it's very easy to ruin it, and you hate to ruin it at this point because you've got a lot of time invested. So I'm going to do this on the belt sander. Some of you may consider that a no-no, but I'm going to set the belt sander table for this angle and just put it on there and round it ever so lightly. Then we'll come back, look at the angles, and talk about honing. This is the 6-inch Delta band sander, belt sander I should say, so I need to tilt the table, but I do not know how much. I do not know this exact angle, so rather than use the protractor back here, I'm going to loosen the table again and the stop, and you can't see it from here, but I'm looking from this angle because this surface here is the same as the belt, and I'm going to raise it and lower it looking from this direction until I get the same angle. So looking at it from this direction, can you see that the two angles match pretty well? And looking at the protractor here, I'm at 11 degrees. So now I'm going to turn the grinder on and just swing a little bit of a radius. How much? Well, I think the drawing calls for about a 32nd of a radius. Now this will only take a moment because we're not removing very much. Again, I have to work at this end so the corner of the block right here does not strike the wheel. That's why I'm way over at this end. You might be well advised to use a smaller, like 2x48 sander rather than this big one, but this lends itself better for photography. Can you see that nice little radius on the end? Now remember, this is soft steel. So I mean that just took a moment, and you can imagine how quickly that would happen on the grind wheel. Matter of fact, you probably would ruin it. Now I don't want to spend a lot of time on honing. I never do. It might help. Some people are obsessed with it, but the idea would be put a little oil on your stone, clean your stone, but it's very hard to hold it on there and get a consistent angle without possibly dulling the very edge that you need. And I would rather drag it than run it back and forth. And you need to do that on all, well, really just this side and on the top. Would probably do it on high-speed steel. Again, we got a big burr here, so you also can use a little hone like that and dress it up. Now let's take the facing tool out of the jig. This is hard steel, and I am not going to put a radius on the end of it, but it would need to be honed just a little bit. All right, let's measure the angles compared to the South Bend gauge. And looking on this, and we'll do the bottom one here, the side tool, which is a facing tool. And you can see that there should be between 20 and 30 on the end, and 10 degrees on the side. So looking at the gauge, it says clearly here, front clearance, 15 degrees, it calls for there. And this varies depending on what materials you're going to cut. But for general purpose, this is just fine. And the side clearance of 10. And then these two notches, this one's for cast iron, while we're interested in steel. That's the angle of keenness, which is this angle right here. And you can see that, oh, I have a little bit less than what it calls for, but it'll work, I guarantee that. All right, let's check the others. Some of you will be using quick change type holders, others will be using this type of holder, Armstrong type of holder. So let's check the side angle, and this is going to be very hard to show in a video. But this is the side angle. Oh, that doesn't show up at all, does it? Maybe this way. I know that doesn't show up on the screen, but it's pretty good. Again, it does not have to be exact, so do not get carried away. Now, as far as the end clearance is concerned, now if you don't have enough end clearance, remember it's going to rub. Maybe I need to set this light back here. So you can see I have a lot more clearance probably than what I need there, which makes the tool more delicate. But let's put this in the Armstrong holder, because these holders hold the work at an angle of, oh, I forgot what it is, 12 or 15 degrees. So let me do that. I might also point out that different brands of tool holders hold the tools at different angles. This one is rather shallow, but checking the end clearance, am I on the right one? Front clearance, they call it, same thing, front relief. And it's quite good. Not right on, again, it does not matter. And again, we could check, well, let me check the side clearance. That will not be any different than the other holder. That's spot on. Well, it's spot on because the 10 degrees is built into this. You can imagine how hard this is to do freehand, but how much faster it is freehand once you catch on. And if you use this system for a while, oh, you know, a year or 6 months or something like that, eventually you'll say, ah, that's too slow. And by then you might have mastered doing it freehand. But the hardest part is getting the consistent angle without the facets that I talked about. So that's the beauty of it. This was a pretty long video, but I only touched on angles and all of that geometry, so I'll be covering that more, as I told you, in the next video, so be sure and watch that if it interests you. Leave me a thumbs up if you like these videos, because my channel is suffering, so that might help me a little bit. And give this a try. Always start with soft steel because it's cheap and forgiving compared to the high speed. Also, the color of the sparks wasn't what I thought it would be. There's a lot of different alloys of high speed steel, and some of them are cobalt or have cobalt in them, and so you're going to get different spark colors for different steels, and that is a way of identifying steel. I have never really talked about that very much. Again, thank you for watching. In the comments, if you like this, let me know. And if you made one of these, let me know. Don't forget what I told you about the blueprints. Those are available now. And always look in the description below, because I quite often give corrections or additions or other information that might be useful to you. Also, sometimes I have a card up here that would help you. And go back and look at those old videos as well. So I think I beat this subject to death. This is Mr. Pete saying so long for now. Looking at this picture, you can see that tool angle there is the angle of keenness, and that's what I was attempting to measure on this facing tool for steel, and it really is about right on. Again, it isn't photographing real well at all, but one other picture I want to show you real quickly. In this South Bend picture, this is actually a little sketch so that you could make your own gauge. But notice that this came out of a real old book, and someone sent me this, and someone had made notes in pencil. So that's what you're seeing here. I didn't do that, but again, it's showing here, right here, to check the angle of keenness, the end clearance, and the side clearance. So this is really neat, and I think I will make a standalone video that about this and talk more, because it's a pretty neat tool. And matter of fact, that was a project that I had the kids make at school as well to help them, because they could make this really in about 15 minutes, but well, more than that. But the problem is I would give them a sketch like this, but they would want to take someone else's, you know, and just real quickly. They didn't even use a pencil, you know. How they were in such a hurry, I don't know why, but they just wanted to trace it around, bandsaw it out, and, you know, I'm done. So, nature of children.